In our previous lessons, we said an index is a number with a power. Now, how do we deal with situations where the power is a fraction? Hello everyone, this is Raiwan Khare with Junior Certificate Mathematics lesson, and the topic for today is fractional indices. With me, it's a learner from Lenzi Junior Community Secondary School by the name Bame Putero. She'll be helping me in today's discussion. Before we go on with our discussion, let us have a look at what's going to guide our discussion today. That is the lesson objectives. The lesson objectives. The lesson objective says use and interpret simple fractional indices. That is, we are going to use and in the process interpret what fractional indices are. Now, before we go further with this lesson, let us have an understanding of what a fractional index is. It says a fractional index involves a situation where the power is a fraction. So, what we're simply saying here is if you got an index, say 100 to the power 1 over 2, this is a fractional index because the power is a fraction. Other examples can be 16 to the power 1 over 4. This is also a fractional index because the power is a fraction. So we are going to be dealing with this situation today where the power is a fraction.
Thank you, sir. How do you evaluate fractional indices? I seem to be confused, and I believe that with an example to illustrate your point out, I will be able to understand.
Thank you, Bami. You are saying, how do we simplify fractional indices? Before we can simplify those, let us have a look at the general form of a fractional index and then interpret it. Let us consider x to the power 1 over 4 equals to the nth root of x. What this simply means is you are to find a number such that when you multiply that number n times, you will get the number x. And we read this as the nth power of x. It simply says find a number such that when you multiply that number n times, you are going to get the number x. And then to elaborate on this, let us have a look at some examples which I believe will help us understand this concept further. Let us have a look at 81 to the power half. But before we can work on this, remember we said x to the power 1 over n is the same as the nth root of x. Now, by comparison, we can see from here that our x here is equals to 81. And then our n is equals to 2. N is equals to 2. So how are we going to evaluate this? This simply says we are to find the square root of 81. When it's a 2, we say it's a square root. When it's a 3, the cubed root. But because we are still concentrating in a situation where we are saying evaluate 81 to the power half, let us simplify this first. Right. It's 81 to the power half. This is the same as, upon substituting here, because we said our x is 81, our n is 2. So upon substituting here, we are going to get the square root of 81. And then there's a 2 here. I want you to understand that here we are saying the square root of 81. But then, usually 1 is the square root. We don't write this 2. The square root sign, which is this sign, simply says there's a 2 here. So we'll just write this as the square root of 81. And then what does this mean? This is simply saying find a number such that when you multiply that number 2 times, you are going to get 81. Now, you are not supposed to use your calculator here. You need to check by trial and improvement. That is, you check. You are looking for a number such that when you multiply that number 2 times, it should give you 81. Check. 2 times 2, that is 4. So it cannot be 81. 3 times 3 is 9. It cannot be 81. So you keep on checking. That is what we call trial and improvement. And then the square root of 81, we'll find that when we multiply 9 times 9, that is what is going to give you 81. So 81 to the power half, which is the square root of 81, it's equals to 9. This is simply saying find the square root of 81. And then the square root of 81, as we read it, is 9. The number that when you multiply that number 2 times will give you 81 is 9. 9 times 9 is 81. So that's how we interpret the square root sign. Now, what about if you are to look at another example? Let us have a look at this. 16 to the power 1/4. What does this mean? The interpretation of this 16 to the power 1/4 is find a number such that when you multiply that number by itself 4 times, you are going to get 16. A number such that when you multiply that number 4 times, you are going to get 16. And then this one, remember, from the example that we have dealt with, we said you are to find the square root of 81. Now here, we are saying find the 4th root of 16. We are saying the 4th root because now instead of a 2 here, you can see that we got a 4. So it's the 4th root of 16, which now can be written as 16 to the power 1/4 is the same as 16. Here, the 4 is supposed to be written. You need to write this 4 because you are saying you are looking for the 4th root. The only time where you don't write the nth term is when you are actually taking the square root. That's when you get a 2. You don't write the 2. But when you are looking for the cubed root, which is a 3, you write it. When you are looking for the nth, when n is equals to 4, like in this case, you write the 4. So this is simply saying the 4th root of 16. Find a number such that when you multiply that number 4 times, you are going to get 16. And then, like I said, you check. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the 4th root of 16 is 2. So this is our answer. 4th root of 16 is 2. A number such that when we multiply that number 4 times, you are going to get 16. And then 2 times 2 is 4, times 2 is 8, times 2 is 16. So the 4th root of 16 is 2. And then let us have a look at the last example under this part. The example here, 27 to the power 1/3. This is simply saying find a number such that when you multiply that number 3 times, you are going to get 27. And then what is that number? Like I said, you need to check this by trial and improvement. So this can be written as the cubed root of 27, meaning you are to find a number such that when you multiply that number 3 times, you'll get 27. Now this will be 2 times 2 is 4, times 2 is 8, so it cannot be 2. Check. The next number 3. 3 times 3 is 9, times 3 is 27. So the cubed root of 27 is 3. This is how, or rather this is how we interpret a fractional index. It simply says when a number is raised to the power to a fraction, like in this case it's 27 to the power 1/3. This simply says the cubed root of 27.
I'm starting to understand, except that the numerator of the power seems to be always 1. Is that the case?
Thank you, Bami. Your question is, it's like always the fraction in our indices, the numerator is always 1. That's not the case. There are situations where the numerator for the power is not 1. But before we get into such examples, let us have a look at the general rule here, which will help us understand that concept better. We've got x to the power m divided by n equals to the nth root of x to the power m. And then how do we come up with this? This rule is from the power of power law. Remember when we discussed the laws of indices, we said there's a power of power law. And this is from the power of power law. It simply says x to the power 1/n. All this raised to the power m is equals to the cubed root of n, all this raised to the power m. The cubed root, the nth term of x, all raised to the power m. and this part here is from the power of power law. You can see that whatever what we are having here, m divided by n, this is the same as 1 over n times m. So when we split this part, we'll have the nth root of x here raised to the power m. And then to elaborate this, or rather make this more understandable to you, let us have a look at the examples which will clarify this. The first example is this: 25 to the power 3 over 2. Our exponent is 3 over 2, which is a fraction. And then, how do we simplify this? First, this can be written as 25 to the power 1 over 2, all raised to the power 3. Remember, we can break this fraction here, 3 over 2, as 1 over 2 times 3. And then, this is what we have done here. It simply says 25 to the power 1 over 2, all raised to the power 3. This will be square root of 25. This is simply saying find a number such that when you multiply that number by itself, you'll get 25. And then after getting that number, what do? You cube it. So this can just be written as the square root of 25, all raised to the power 3. Square root of 25, all raised to the power 3. So find a number such that when you multiply that number by itself, you are going to get 25. Then after getting that number, what do? You cube it. You raise that number to the power 3. So this will be the square root of 25. It's 5. And then after getting this 5, what do? We raise this 5 to the power 3, because it says find the square root of 25 and then raise it to the power 3. And then this will be 5 raised to the power 3, and this is equals to, this is simply saying multiply 5 3 times, and then 5 times 5 is 25, times 5 is 125. So 5 cubed, that is 5 raised to the power 3, it's equals to 125. And then you should have realized that in this question, like I said, the numerator is not a 1, like in other examples that we started with. It's a 3. So upon simplifying this, we said, no, find the square root of 25. After that, raise it to the power 3. And then this is what we got. 5 to the power 3 is 125. Let us have a look at another example to make this more understandable to you. 32 to the power 2 fifth. 32 to the power 2 fifth. How do we simplify 32 to the power 2 fifth? This is the same as 32 to the power 1 over 5, all this raised to the power 2. We just split in 2 fifths into 1 over 5 times 2. And then from there we'll find the fifth root of 32. Then after getting the fifth root of 32, we now square it. So this will be the fifth root. Remember, when a number is not a 2, we have to make sure that we write it here. So this simply says the fifth root of 32. And then after getting the fifth root of 32, what do? You need to raise it to the power 2, because it says 32 to the power 2 fifth. So first find the fifth root of 32. Then after finding the fifth root of 32, you square it. And then what is the fifth root of 32? A number says that when you multiply that number 5 times, you are going to get 32. You check by your trial and improvement. 2 times 2 is 4 times 2, that is 8 times 2, that is 16 times 2, it's 32. So how many times have we multiplied 2? 5 times. So the fifth root of 32 is 2. But then remember to raise this to the power 2, which is this one, that is the 2 that we are having here. So raise this to the power 2. And then 2 to the power 2, what do we get? 2 to the power 2. This simply says multiply 2 how many times? 2 times. So 2 times 2, this gives 4. So what we are simply saying is 32 to the power 2/5, it's 4. Upon simplifying, this is what we got. We got 4. This is how we evaluate fractional indices. This is how we evaluate fractional indices. And then there is another example here. 8 to the power 4 over 3. This will be the cubed root of 8, or this raised to the power 4. The cubed root of 8, or this raised to the power 4. This is simply saying find a number such that when you multiply that number 3 times, you are going to get 8. And then after getting that number, you raise that number to the power 4. This then will be the cubed root of 8 is 2. You can just check. 2 times 2 is 4, times 2 is 8. So the cubed root of 8 is 2. Then we raise this to the power 4. This will be 2 to the power 4. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the answer here is 16. You will realize that I'm giving examples which the numbers are very small. I want to believe you'll be in position to deal with them. This is because we expect you to use the trial and improvement method, where you'll be able to say find the cubed root of 8 and then raise to the power 4. We are not giving very large numbers. Welcome back from the short break. Remember, we are discussing fractional indices, and I'm still with a learner here from Lenzi Junior Secondary School. Now, let me give Bame another opportunity to ask a question before we end this lesson.
I have now understood fractional indices, but before I let you go, can these fractional indices be multiplied or divided? If so, please present an example of each.
Thank you, Bame. You are saying how do we multiply or divide fractional indices? We've got examples here which will help us elaborate more on the multiplication or division of fractional indices. Let us have a look at the first example. The first example is 5 to the power 4 over 3 times 5 to the power 2/3. And then it says multiply this. Now, this 5 to the power 4 over 3 simply says find the cubed root of 5. Then after that, raise it to the power 4. Now, can you find the the cubed root of 5? You check. You cannot. So don't panic. Just apply what you have learned in other lessons. They are what we call the laws of indices. The laws of indices simply says when the base are the same, keep the base and then add the powers. So here we can't find the cubed root of 5, then from there raise it to the power 4. But rather we'll use the other concept that we have learned before. So this will be 5 to the power 4 over 3 plus 2 over 3. Not 2 over 2, but 2 over 3. And then this will be 5 to the power 6 over 3, which is equals to 5 to the power 2. You just need to apply what you have learned in other lessons. And then upon simplifying this is what we got. 5 to the power 2. And then what is 5 to the power 2? This simply says multiply 5 how many times? 2 times. This will be 25. 5 times 5 is 25. So we have managed to simplify this. 5 to the power 4 over 3 times 5 to the power 2 over 3. That's how we simplify it. Let us have a look at another example. The other example is this. 27 to the power 2 over 3 divided by 3 squared. So we've got a fractional index here, and then we are dividing it by 3 squared. Then how do we do this? First, we need to evaluate what 27 to the power 2 over 3 is before we can divide. So let us evaluate what 27 to the power 2 over 3 is. 27 to the power 2 over 3. It's equals to the cubed root of 27, And then after finding the cubed root of 27, what do? Square it. That's how we do it. Find the cubed root of 27. Then after finding the cubed root of 27, square that. So this will be the cubed root of 27. Find a number such that when you multiply that number by itself, how many times? 3 times. You are going to get 27. That number is 3. 3 times 3 is 9, times 3 is 27. So the cubed root of 27 is 3. And then it says square it. That's what it says. Now, remember, the question did not say evaluate what 27 to the power 2 over 3 is. It says find out what 27 to the power 2 over 3 divided by 3 squared is. So we have evaluated what 27 to the power 2 over 3 is. And we got this as 3 squared. And now this is what you are going to do. You are now going to say 27 to the power 2 over 3 divided by 3 squared. It's equals to 27 to the power 2 over 3. It's 3 squared. We evaluated this and then we got 3 squared. Remember 27 to the power 2 over 3, upon evaluating, this is what we got, 3 squared. Then divide this by, because it says divide 27 to the power 2 over 3 divided by 3 squared. So divide this by 3 squared. And then this will simply be 3 to the power 2 minus 2. Remember the laws of indices. It says when you divide, you subtract the powers. So this will be 3 to the power 2 minus 2, which is equals to 3 to the power 0. And then what did we say about a number raised to the power 0? We said any number raised to the power 0 is equals to 1. So this is equals to 1. So 27 to the power 2 over 3 divided by 3 squared is equals to 1. We managed to evaluate this. Let us have a look at another example. We have this. Okay. We've got 27 to the power 2 over 3 times 16 to the power 1 over 4. So here, this first part is a fractional index. The second part also, which is 16 to the power 1 over 4, is also a fractional index. And we need to evaluate this. We will now make sure that we start by evaluating what 27 to the power 2 over 3 is. This is simply saying find the cubed root of 27, and then after finding the cubed root of 27, what do? You square this. And then the cubed root of 27 from the last example, we find it to be 3 to the power 2. This is 27 to the power 2 over 3. This is 3 squared. This is simply saying find a number such that when we multiply that number by itself 3 times, you are going to get 27. That number is 3. You can check. 3 times 3 is 9, times 3 is 27. Then raise that to the power 2. And that's 3 to the power 2. And then what about 16 to the power 1 quarter? We need to evaluate this as well. 16 to the power 1 quarter. This is the fourth root of 16. And then what does it say? It says 16 to the power 1 quarter. The fourth root of 16 raised to the power 1. When we raise a number to the power 1, it doesn't change its identity. So we'll just find the fourth root of 16. A number such that when you multiply that number by itself 4 times, you are going to get 16. And that number is, you can check, 2 times 2, it's 4. 4 times 2, it's 8. 8 times 2 is 16. So the fourth root of 16 is 2. And then, what was our question? Let us have a look at the question. The question says we are to evaluate what 27 to the power 2/3 times 16 to the power 1 quarter is. Now, we have evaluated what 27 to the power 2/3 is. And we found that to be, that is 27 to the power 2/3 times 16 to the power 1 over 4. This is equals to 27 to the power 1/3. We found this to be 3 to the power 2. And then says multiply this by 16 to the power 1/4. That is the fourth root of 16. The fourth root of 16 is 2. We evaluated this and we got 16, rather 2. Fourth root of 16, this is a 2. And then the cubed root of 27 raised to the power 2 is 3 squared. And that's what we are having here. So this will be 3 squared is 9. So this will be 9 times 2. 3 squared, this simply say multiply 3 2 times. So this will be 3 times 3 is 9. Then multiply by 2. This will be 18. So we have evaluated. So 27 to the power 2/3 multiplied by the fourth root of 16 is 18. This is what we have done. We have now come to the end of our lesson. But before we leave, let us have a look at what we covered today. We have the rule which says x to the power 1/n is equals to the nth root of x. This is simply saying, there's an n here, this is simply saying find a number such that when you multiply that number by itself n times, you'll get the number x. And then in addition to this, also we discussed this rule which says x to the power m divided by n. This can be written as x to the power 1/n all raised to the power m, which is the same as the nth root of x, all this raised to the power m. So these are the two basic rules that we discussed today. And upon studying these, they will help you understand fractional indices even further. I want to believe you have enjoyed today's lesson, and this is all that I have for you. Until we meet again in the next lesson, thank you.